Well, it is a blessing to be here. Always a blessing. You always treat me like family, and my good wife as well. Now, you instantly noticed, you don't sound like the Dr. Guliuzza we all know and love. That's because I came from a conference right before here, and of all places, it's like your sister state on the East Coast, New York. So, you know, New York kind of divides into, there we go, into the city and then the rest of the normal state. And then and California kind of has a little bit of that same feeling. And it seems like when I come north of San Francisco, I get into this world of normalcy. And then like below San Francisco, it starts to change a little bit. Oh, hey, I didn't say for the worse, I just said change. You could just use the word they're different. So, or peculiar. Anyway, I spoke a lot last week, and I got laryngitis. And then I think I got a viral infection, which was a setup for all that speaking. And believe it or not, I sound a lot better than I did just 48 hours ago. 48 hours ago, it was like joy from my wife. I couldn't talk at all. And so this is a big improvement. Okay, we don't have a whole lot of time, and I wanted to take your brain and remold it, if I may, into some new creationist thinking. And I can do this because you guys are, wow, this is strange here. You guys are creation savvy. Oops, there we go. There we go. All right. Very, very creation savvy. You know what I mean by that? You've had a lot of creation thinking before. And some of it is, I'm going to do this talk again at Friday night for Simpson College. Some of it has been good and some of it has not been good. And I'd like you to go to a scientific lecture, since you are very creation what? Savvy. And if you went to a scientific lecture, this is what you would see. You would see a hall full of posters where scientists put together a big poster and they are going to tell you about their research. And then on breaks, people walk around and they look at the posters, and someone wants you to at least show a little interest, so they bribe you with candy or something like that to come listen to them talk about their poster. So we have a scientific poster here right now. And it's going to talk about a new way of doing creation science, which should be a no-brainer. That's using design analysis. Design analysis works because creatures are what? Designed. So if we use design analysis, we should be able to understand things better. Now, we were all taught that as we are from little kids up, that we have an immune system. Your immune system is meant to fight off all of those biological invaders which are here to hurt and harm you. Well, you know what? That's probably not the best explanation that's been out there. And we probably can come up with a much better explanation if we go from a design-based perspective and a biblically based perspective. And so I'm going to use design analysis to show that it's what we probably call an immune system is better, much better characterized as an interface system. And it's going to begin with research of a creation scientist who's actually from California here. His name is Joseph Francis, and he teaches down south. And he had an interesting thought about 20 years ago. In fact, it was a leading thought that bacteria, instead of being our enemy, they were probably created by God for our good, and they form a vital organosubstrate of life. Even bacteria that we call harmful bacteria. And this is a picture of one that's called treponema. It's actually a very pretty bacteria when you magnify. Look at it, it's a little corkscrew, but it causes syphilis. So generally you don't want this bacteria. And I'm not saying that Dr. Francis has this bacteria. All I'm saying is that according to his thinking, there was a time when he peacefully coexisted even with treponema. And he's right. So first change of thinking is let's start viewing these microbes not as our enemies, but as really friends and vital necessary friends. That's the first change. And then the second, let's bring in another research method, and that's called design analysis. And I really wish a lot of my biological associates could adopt this. Biologists generally, they take something like this and they take it apart. You see my little clicker? They take it apart to try to figure out how it works. And that's a very hard process because you don't know, if you didn't know how this worked, you wouldn't know exactly how to line up all the parts and things. But let's say we ask the question of our biological friends that we would ask of our engineers, how would you build a thing to advance slides in advance before you started to take it apart? And then you would know exactly what you needed to do it. And then as you took it apart, you'd be able to say, oh, this is that, this is that. You see what I'm saying? You would have a roadmap of where to go. So let's start looking at creatures from an engineering perspective, and we're going to ask this question, and this is the one you want to take down. How in the world would you get two independent, autonomous entities to work together? You're an independent, autonomous entity, and a bacteria is an autonomous entity. You don't just take a bacteria and a human and say, work together. You don't just force them to work together. In fact, they will never work together independently. My mom used to say to me, go play with your sister. What a futile order. It just wasn't going to happen. You know, you just don't order things to happen. So, I already gave away the clue at the title of this talk. How would an engineer get a bacteria and a human being to work very, very closely together? They would have to build it was in the title, an interface. They would have to build an interface to get them to work together. So if engineers were to build an interface, the question is, could God have used an interface? You see how that works? If we would use an interface, could God use an interface in order to get them together? Well, we use interfaces all the time. When I was a kiddo, we hated the Russians, but we tried to get along with them, and we sent an Apollo spacecraft to dock with a Soyuz spacecraft, and guess what they used on the nose? It was an interface. And if you want to get a human being and a machine to work together, you don't just say work together. Someone who designs this John Deere is going to build things that fit into your hands, that your hands can attach to, that are attached to the machine also, and they are going to what? Connect you to that machine. That is also an interface. And you can bet your bottom dollar, whatever that means, that anytime you connect two things together, they will always have an interface. In fact, wow, this is strange. If you want to connect a human being to a drain pipe, you would need what? An interface. You need something that brings the two together. And this is an absolute essential. You see what I'm saying? Engineers always come up with a solution to bring these things together. So, this is not a novel thought. This is an absolute. So the questions would be, if we had a good scientific talk, can creationists derive a better explanation for the immune system that isn't even post-fall? It's pre-fall. It's how God originally designed it. Now that's a great explanation. That's a good way to go. If engineers would overcome this by building an interface, could God have used an interface? And, wow, but we are getting some interesting interference here. That's exactly right. We have the enemy of the interface here. All right. I now notice that we're having some opposition. But there's a lot of papers out there that describe what interfaces do, but I only found really one solid one that describes what an interface is. And this was a paper by some IBM researchers in 2012. And they point out whether a human being is connected to a computer, you can have an interface. And that's called a graphical user interface. So those little icons and stuff that you can touch, they connect you to the operating system. Or if you need to connect to various computers, you're going to need an interface. Or even if you want to connect to a corporation like Amazon, which is dealing with hundreds of thousands of transactions at any moment, guess what they bridge them all with? An interface. So this is an absolute essential. And you could have many, many different ways of doing it. But here's a great figure which demonstrates the key components of any interface. If you go from the machine end, you'll notice that there are sensors, there is a processor, and there are actuators. There's an input, there's a logic center, and there is an output. And look over here on the human side. What do you have? You have the exact same things. You have some kind of sensors to tell you what you're dealing with. You have a logic center. Most of us use that as our brain. And we have outputs, actuators. And these are the essential components of an interface that are going to connect them together. And in fact, there are 3 indispensable interface elements that are very easy to memorize. So the question is, if these 3 elements are indispensable for interfaces, does your so-called immune system have them? Isn't that a good question? Do we have those? And the answer is yes, we do, and I'll go over those first. The first indispensable is authentication, which is a mechanism for identifying self from non-self. If you're going to relate to another entity, you have to know who you are and what that is. That's called authentication. And authentication is going to allow only authorized people to interface with you and keep away the unauthorized. And it's going to control how much you disclose about yourself or it discloses to you. And we all do this all the time. So authentication is an important one. Next, protocols. Protocols are really the heart and soul of any interface. Do we know what they are? They're just rules and regulations governing when, where, how things are going to relate to each other. If you're going to relate, there has to be some rules, and a lot of times they set down specific formats and codes for how 2 things must relate to each other. We're going to camp for most of the talk on protocols, the rules governing how things work together. And then finally, there has to be a common medium where both entities can join up to it. You remember the human sewer pipe thing? There's a common medium there. Both entities have to be able to grab onto this medium from both sides. Does that make sense? And in the world of biology, it's biochemicals. It's the biochemical medium. You engage in biochemical reactions, guess what microbes do? Engage in biochemical reactions, and you both can work together. All right, this is our map, and here's where we are on authentication. The blue box lists all the ways that your so-called immune system authenticates between you and microbes. And I'm not going to go through all of these in detail. I'm just going to give you some examples. But Kim published a paper in 2005 that says self versus non-self discrimination is the central theme in biology from plants to vertebrates, where you identify your tissue from foreign tissue, self from non-self. And this whole picture up here is a cool example of how your body has its white blood cells, and they don't come out just ready to kill things around them. They have to be licensed to kill. They're kind of like what? A James Bond cell. They have to be licensed to kill, and they go through a process in which they will then be able to authenticate something which is not you, and once they're licensed to kill, then they can kill it. They can kill it. So they go through this licensing procedure. It's not just between large creatures and bacteria. Even bacteria relate to viruses. At that tiny microscopic level, they still have authentication systems between a bacteria and a virus. And as this person said, all immune systems must distinguish self from non-self. This is a universal dilemma for every creature. So, authentication is clearly a method of all immune systems. It's absolutely essential. Now, protocols. These are the rules and regulations of how you would relate to a microbe. It's a way to get control over something. Now, there's a couple ways you can control something. I could reach over and I could grab Danny Faulkner. Literally, physically grab him. And I could control him that way because I've got youth and vigor on him, on there. So That just came to my mind. That wasn't planned. But I could physically control him. There. And I could do that. Now that's kind of cool. There's ways to physically control. Let's look at one of those. Operative direct physical control. This is one called the complement system, and it directly physically controls bacteria. When a bacteria gets in your body, or a microbe, certain proteins are elaborated, and they make a little plug. And the plug is hollow. And this is what it looks like on the outside of a bacteria from the side. It has all of these little tubes. And here's what it looks like in cross-section. Here's the tube. And guess what they do? They punch a hole in the cell wall of a bacteria. And as you can see, they don't punch a hole, they punch what? Dozens of holes all over them. And then the fluid of the bacteria oozes out, and it dies. Or other fluids from your body flush in, and it dies. And that's one way to physically control it. Now, isn't that kind of interesting? Right. But you know what's even more interesting? And here's where the talk starts to make a turn, and you need to get some new thinking into your creationist worldview. What if you could control something without having to physically touch it with an interface? And this is what really glorifies the Lord. Because if you're going to build an interface between two distinct entities, the interface designer must thoroughly know how this entity works, and the interface designer must thoroughly know how this entity works in order to get them to work together. Are you following me? You don't have to know one, you have to know them both. And you really have to know them both almost inside and out. What if the interface designer said, if this entity doesn't touch this one, but if this entity presents to this one conditions, certain conditions, that when this one detects those conditions, it will do a specific, it'll have a specific outcome. Isn't that cool? So I don't grab Dr. Faulkner. I just say, if I present to you X, Y, and Z, and you detect X, Y, and Z, you will do 1, 2, and 3. That's really cool. And you know what's interesting is he may not even know I'm presenting to him X, Y, and Z as he tosses out 1, 2, and 3. And I may not even know that he's supposed to give me 1, 2, and 3. I just detect 1, 2, and bring it into myself. In other words, we're both doing it, not even knowing it. But someone knew it, and that someone was the designer who knew it. This is how most things work. And it's much cooler than physically grabbing a hold of something. It's much better. It's really cool. And that's called a condition-consequence process. And engineers do it all the time. We present a specific condition, and it will elicit a necessary and particular consequence. Now, biologists almost always get this backwards because they don't think like engineers. They see the consequence and they think the consequence caused what was happening. Wrong-o. It's the conditions that are presented which lead to a consequence, a particular and necessary outcome. So, let's stop looking at organisms and human beings as enemies. Let's look at them as they probably really are. And I shouldn't even say probably, as they really are, as requesters and providers. Like when you make a request from Amazon, and Amazon is a provider. And you notice it says requester/provider. And it's the host or the microbe. This is cool because at any one moment, your body could be the requester and the microbe could be providing your body something that you need. But at the next moment, the microbe could be a requester and your body could be providing something that the microbe needs. And you're working together. Requester, provider, requester, provider. Is this changing your thinking? It should be. It shouldn't be like, I'm grabbing you by the neck. and rub, and what do they call it here in California? Shaking you down or something like that. They do that in Sacramento. But yeah, that's right. They're requesters and you're providers. And they're requesters and you're providers all the time. This is how it works. Requester, provider. Requester, provider. Now, let's look at a really cool example by this researcher, Barbara McFall. And she's doing research on a tiny little squid, just 2 millimeters long, called a bobtail squid. And what's cool about the squid is it glows in the dark. But it doesn't just naturally glow in the dark. It glows in the dark when it is inhabited by a specific bacteria called Vibrio. Vibrio is one type, causes cholera. But in this particular case, it presents an interesting example of how two things will work together. So these little squiddos are born. And they're dumped into the ocean, filled with thousands of microbes and thousands of different microbes. But as soon as they are born, they can detect, they have little sensors all over their body, they can detect as few as 5 of those bacteria in an ocean of water. And as soon as they detect those bacteria in this ocean of water, they will release a chemical all around them, which only Vibrio have the mechanisms to overcome. All the other bacteria die. And then the Vibrio begin to increase in numbers, and then the squid will release another chemical that the Vibrio can detect, and they follow an increasing gradient, and they move into a light organ inside the squid. Millions of them move into this light organ. And then once the squid detects the Vibrio have moved into its light organ, it releases another chemical which seals them off. They're sealed inside the bacteria for the rest of their life. Right inside there. And then what's really cool is the bacteria, after they follow this, they will detect a chemical that the squid releases called a cryptochrome. And once the bacteria detects the chemical that the squid releases, cryptochromes, they start to glow. They start to glow at night. And that's really cool. But then the squid can detect the glowing of the bacteria, and they, it's like, stand here.
Requester, provider.
And that's right. They release more cryptochrome, which causes more production of light from the bacteria. Now that is really, really cool. Do you see how that works? They're not touching each other. They're not controlling each other. They're just presenting conditions. And when the other one detects the conditions, it does what it's supposed to do. Someone designed these two things to work together. That was the Lord Jesus Christ who put that together, who designed them. Now the little gray thing is a little fun fact. He says that the squid is able to detect those light-emitting bacteria, and then if any of them are not pulling their weight, in other words, are not producing light, it kicks them out. It can detect non-light emitters and selectively eject them from its body, and they're gone. I don't know what happens to them. Anyway, the key thing is this, and this is the thing we need to get new in our thinking. The squid does not cause the bacteria to do anything, and the bacteria does not cause the squid to do anything. Each one is doing what they're supposed to do independently as an autonomous entity when it detects external conditions. The squid does not change any of the bacteria's genes, and the bacteria does not change any of the squid's genes. Are you following me? It's not an externally driven process. It's all internal, and this is how organisms really, really do work. But if you read the scientific papers that describe this, look what the papers always say in an environment-driven worldview. When Vibrio, that's the bacteria, first touches the squid, it changes the expression of scores of the squid's genes. That's not true. And this floods scientific papers constantly. Constantly. And it's not true. And I'll tell you why it's coming this way. This will give you a little preview for Friday's talk. Because you have two worldviews. God creates nature, or nature creates itself. And in the nature creates itself worldview, you must always have the environments driving the show. They must always be running the show. But in the God creates nature, it's the organisms that are running the show. Completely different. In the God nature creates itself, you have to have natural abilities for them to craft and make organisms. And this is how they come out. The bacteria changes the squid. However, that's not true. And here's an evolutionary researcher in 2013 who was perceptive enough to bring this out. He says, in everyday parlance, that's how we commonly talk. Environmental stimuli are said to induce or even regulate the expression of specific genes. That's how 99.9% of the biologists on this planet write. Because biology grew up in a world where you could see environmental things and you could see effects, therefore this caused this, because nobody could look inside creatures way back then. But now we can. He says this notion is so engraved in the biological conception system that it comes as a what? A revelation. We need to have more biologists have the revelation. When upon closer scrutiny, it turns out that no external stimuli could directly induce the expression of any gene or known. You know who's expressing, and you know who's controlling the expression of your genes right now? You are. The Lord set it up that way. You are. Your body is controlling itself. So creatures self-develop. They self-maintain. They self-repair. They self-adjust. When you make something that can do all that stuff, that is an incredible feat of engineering. And that's what really glorifies the Lord. That incredible feat of engineering. And this is what creatures are doing. Right there. It's volume.
Less than 50 years of delay, but we have been able to offer drivers peace of mind. 50 years of designing cars for crash survival that led us to our most revolutionary feature yet. A car that can see trouble and stop itself to avoid it.
Now, is that a great engineering achievement? Yeah. Sure it is. Do you see that proud engineer there? Of course he was. Did you see what they said? The car stopped what? Itself. The car stopped itself. I guarantee you there's a sensor on this car, and there's a computer in this car, and there's actuators on this car. This wall did not stop the car. You know what the wall is? It just is. It's either there or it's not. And when it's there, the car, what? Stops itself. Please let me encourage you to start seeing yourself as this way, and organisms as this way, as these great engineering achievements. And please start eschewing, we'll pick this up on Friday, that environments are driving the show. Wow, we'll pick up some examples on that on Friday. Right there. This is a new axiom, that 100% of functional causality originates from within the object designed. You know how I know that's true? Because I was an engineer before I went to med school, and I designed things. And I realized you must build in what you want this thing to do up front. And if you don't put it in up front, no environment puts it into it. It doesn't happen. You must build it up front. We need to move away from this environment-driven worldview, which, by the way, in their worldview, the environment is driving the show, and the key element of the environment that's driving everything is death. It is a death-driven, death-dominated worldview where creatures are getting eliminated, leaving only a few. It's a death-driven, death-dominated worldview where environments are driving the show, and the mechanism they use to drive it is death. Whoa. This is what's really happening. This is a kind of a busy picture, but it's easy to understand. Here's organism 1 with a distinct boundary. Here's another organism over here with a distinct boundary. And they're going to relate to each other through some kind of authentication system. Once they do, organism 1 here, or organism A, it has all kinds of external conditions. Some triangle conditions and some of those conditions, and even star conditions. Look what's on the outside of organism A. A little detector for that, and a little detector for that. And when it detects any one of these conditions, it goes to a logic center that says, if this, then do that. And it has all kinds of outputs. One output could be to put a product that stimulates the thing itself. Another could be a product which could be put into the environment, which when this one detects, it dies. Another one could be a product that it puts in here, when this detects, it makes another product. Or they can make products for themselves, or they can put a signal for this organism to self-destruct, or it can modify its own DNA. That's what can happen. Now you notice the stars are here. Are the stars a stimulus for that organism? The answer is no. Even though they're in its environment, they're not a stimulus because there's no detector for them and there's no if-then mechanism to handle them. Do you see what I'm saying? You must have a detector and you must have logic for anything to be a stimulus for you. How many of you right now are being bombarded by AM radio waves? All of you are. You're all being bombarded. How many of you are listening to AM radio in your head? There's a guy who raised his hand. Please see me afterwards. I'll get you some medication for that, but you're not listening to AM radio in your head because God never equipped you with a what? Detector, and then some way to process it once you got it. There's no interface. That's exactly right. We're looking at the elements of an interface. Could God have put that in your head? Of course he could. He put all kinds of interesting sensors and detectors and interfaces for us right now. Right now I'm interfacing with you. I have vocal cords, when they're working right, they compress the air. And compressed air packages go across the room, and then you what? You detect them with your ears, but more specifically your eardrum, which is your tympanic membrane, which senses those vibrations, and then it sends a signal in. That's an interface. That's how one of the ways we interface with each other. Now this is really cool. So what this is saying is nothing outside of you in and of itself is a stimulus. It must be defined to be a stimulus by a designer who will say, this is a stimulus, but this and this and this are not. And then the designer will put on your body a detector for that thing, that condition, which they specify to be a stimulus. So stimulus, this is hopefully new thinking. They're not just out there. They are defined to be a stimulus. And once it's defined, and once you're equipped, then this will be as we would say in engineering, a specified stimulus. Plans and specifications, we specify certain things. And there's a detector. And then this organism here, guess what? When it detects that, it goes to its if-then mechanism. It says, if this, then do that. Boom. It pops out a product, and it dumps it into the environment. And this organism detects that product. It has a sensor for it, and it puts it into its logic center. And neither one of these things are necessarily touching the other. They're just doing it. And the person who put this together thoroughly understands them both. Now let me ask you this. How many organisms on this planet relate to each other? All of them do, in one way or another. So the person who put all of these interfaces together had to know everything about all of them. Now you should be saying, praise the Lord. I mean, this is showing you from a design perspective how this has to work and how much genius the Lord had to have and how much he had to know in order to get everything to work together. I mean, this is just, he knows everything. And I had to learn it. Oh, rats. There we go, we're back. And the interface is back. Now, how can this work in biology? Let's look at some examples of this. Let's go to these cave fish. I'm going to bring these up again on Friday. Look at this. This fish doesn't have any eyes. And this one does. And sometimes these fish can migrate into caves, and then their eyes are gone. Now, the typical story we're told is, well, they migrate into caves, and eyes are no good. Therefore, they kind of bump into walls and rub things. They become diseased, and then instead of becoming an advantage, they become a disadvantage. And over many, many, many generations, the environment's select against them, and they go blind. Isn't that the story we're told? It is. Everybody tells that story. The trouble is, it's probably wrong. Probably totally wrong. And I even published an article in our news magazine, which we give out free, in 2009, 10 or 11, something like that said this story is probably wrong. In fact, not only do fish go blind and lose their pigmentation, but crayfish do, worms do, all kinds of creatures do when they find themselves in the caves. As I was looking at this, I said, this looks like a design process so that organisms can be fruitful, multiply, and fill the earth, including caves. Well, once they get into the caves, they adjust. They self-adjust. And it's also interesting that the space in the skull, which was occupied by the eyes as the orbits, once those eyes are gone, other brain tissue elaborates, increasing the fish's sensitivity to sound, its sensitivity to motion, its sensitivity to all kinds of things. So I put in Acts and Facts a prediction that said there's probably a light sensor in these little fish that when they have their babies, they detect it and they lose their eyes. That was kind of a prediction. And it came out, and then lo and behold, in 2013, this paper was published in Science. It says, cryptic variation of morphological evolution, HSP is heat shock protein 90. It's a protein. The bottom line is this. The fish parents detect when they're in the cave. They send a signal to their developing embryos. This protein is regulated as the embryos develop, and in one generation, not many, many generations, in one generation, they can go from eyes to eyeless. Just like that. Now that's an interesting thing. What in the world? And not only that, depending on how much of this, oh no, that's okay. Oh, it's getting bad vapors or something. But that's okay. And as soon as we touch it, it'll be dead forever. Because, as a pastor told me one time, we don't fight the prince and the power of the air. We fight the prince and power of the airwaves. And he loves to get into electronics. But they are, they depending on how much this is expressed, they can have partially diminished eyes to all the way to blind. Wow, that's really cool. Here's some mice. And I think I might have mentioned this last year, but it's a good story. These are male mice. When they're put on an electric pad, and they're exposed to cherry blossom odor. And as soon as they're exposed to cherry blossom odor, the electric pad gets a little shock, and it shocks their feet in a painful but not lethal way. And biologists do this stuff all the time. They expose them to cherry blossom odor, shock them. Cherry blossom odor, shock, 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 shock. And they shock these male mice ad nauseum every time they get exposed to cherry blossom odor. Then they take these male mice and they mate them to naive female mice. Now, what's a naive female mouse? Well, it's not the same naive females that humans are looking for, but it's a female mouse which has never been exposed to cherry blossom odor ever. Ever. And then they mate, and they have offspring. And they take these little offspring, and unfortunately, they sacrifice them. That means they kill them. And they go to their olfactory region where they smell, and they stain it looking for olfactory sensors, and the nerves. And here's the... Oh, so annoying. Here's the... I know. We could lay hands on this. Here's the nerves and the sensors of cage with no odors. Here's neutral odors and no foot shocks. Sensors and nerves. Look at this. Sensors and nerves of offspring, of children, of offspring of fathers that had foot shocks and cherry blossom odors. And they've never smelled cherry blossoms, but they already have a receptor increased for that. Now this is interesting, and the DNA never changed. The DNA didn't change. There were markers put on the DNA which changed the expression of the DNA, which controlled the development of these sensors and these nerves. Now, wow, this might, let's say it wasn't cherry blossom odors, this might allow the offspring of these male mice to detect other things in their environment that they need to know. Now this happened in one generation, and it persisted for others. And then look at these beaks. And look at all these different beaks. They're all finches, and they all have all these different kinds of beaks. And you can get big beaks, short beaks, and little beaks, and things like that. And beak development happens as a little embryo inside the egg. So you know mom isn't doing it because mom already what? Laid the egg. It's outside of her. And depending on how calmodulin or bone morphologic protein 4 are expressed in various amounts at various times during embryo development, you can get a long beak like this, or you can get a short, powerful beak like this in one generation. And what's interesting is this paper was published in 2014. Shared developmental program strongly constrains beak shape and diversity in songbirds. And what's cool about this is all of those beak shapes can be reduced to this equation, which means you can put in different variables here and you get a different output here. Does everybody follow that? Different variables, different output. Condition, consequence, programming. And it showed definite limits to beak shape. In other words, beak shape does not go on forever. There's definite limits to beak shape, but between those two limits, you can adjust the gradient finer and finer and finer to where you get all these different kinds of beak shapes. Now that's probably a better explanation for Darwin's finches than some death-driven process over that. Now how can other creatures use this to obey the Lord's commands, to be fruitful, multiply, and fill the earth? Well, here's one way. This is a report on a wood rat. Wood rat is actually out here in the California area. Now normally this wood rat lives in areas where creosote plants are not growing because it cannot eat creosote plants because they're toxic. However, if you change the microbes in the gut of this wood rat, which its interface system, which we used to call an immune system, is closely regulating, then guess what? It can eat creosote because the microbes will detoxify it. And now it can become food. Now it can become food. And that's what this says. Here we demonstrate that gut microbes are crucial in allowing herbivores, that's the wood rat, to consume toxic plants. These results demonstrate blah, 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 that it allows this to move into different environments. So, how can creatures rapidly fill the earth after creation? How can creatures rapidly fill the earth after the flood? Well, there may be mechanisms which require no genetic changes. It could just require changing the gut microbes and allows you to fill the earth. And that's very fascinating. And the interface system is controlling it. In fact, your interface system can adjust your gut bacteria within 24 hours. So that I came from New York and I'm eating quahogs or whatever they eat up there. And I come out here and I eat sprouts and stuff like that. And rapidly, in 24 hours, my interface system is regulating my gut bacteria so that I can go all over the country and eat their different food and stay relatively healthy on that. That's interesting. And then this is one. The paper just came out in June of 2015. Mother's Little Helpers. Breast milk nourishes microbes colonizing baby's intestinal tract. And it calls it that this is really a highly regulated system. But the bottom line is this. Mom is in a specific environment. Baby has now been born into that environment. And mom's gut microbes are already adjusted. Maybe we want baby's microbes to be adjusted as well to live in the environment that she is living in. Guess what's adjusting them? Changes in breast milk which baby eats adjusts baby's gut microbes to live in mom's environment. And in fact, I just read a paper about a month ago. This was totally fascinating of how these two, guess what? This is hooked up by what? An interface. Is mom adjusting baby's genes? No. Baby adjusting mom's? No. There's an interface system here that's doing that. Mom's intestinal cells can actually grab some bacteria, encapsulate them alive. It goes into her blood system, comes up, it's expressed in her breast milk. Baby drinks those. His system unencapsulates the bacteria and puts them in his gut. This is the kind of design we creationists should be on the cutting edge of expressing and do biology as if Darwin had never been born. That's how we need to do it. And this really glorifies the Lord. So, what are some practical applications for creationists? First, for building a model, which we want to have a non-evolutionary model, from a design perspective, the immune system, this fight 'em off, save you from death system, could be more accurately rebranded an interface system. Because that's what it really is. It interfaces between you and your microbes, and it's regulating those microbes. Pre-fall defensive systems are kind of hard to explain. How many of you have ever been asked, well, why did God put an immune system in you before there was a fall? They're hard to explain, and they appeal to foreknowledge, and they appeal to omniscience, which are never good theological explanations. When I was at Moody, as a Moody student, they said, you better not explain this by saying God foreknew it, because the fact of the matter is God foreknows everything. So what can it explain? Why are you sitting here today? God foreknew it. Why do you have your hand on your mouth? God foreknew it. Why do you know what I'm saying? There's other reasons for doing that. He doesn't want to get my germs, and that's why he's covering right there. Humans have associated with microbes since creation, so a microbe interface system was a design certainty. You see what I'm saying? You must have it. And if we were thinking like engineers, way back, we would have been looking for it. Because without it, you will never relate to microbes. You see what I'm saying? It's impossible without it. The microbe interface system is likely not much changed from its original and continuing purpose of regulating microbes. So right now, what you call your immune system is really your interface system. It's regulating so-called good bacteria, and it is regulating bad bacteria. But it's not doing it for defensive purposes. It's just regulating, which includes act of destroying those cells, so that you can fit and fill different niches. So cell-destructive capacity, not for defensive purposes, but for regulatory purposes, has always been there. Adam had it. Eve had it. They had this capacity, and it wasn't to keep them from getting sick and dying. It was simply to just regulate the bacteria on their skin, in your gut, in your lungs, all those places that interface with your environment. Okay, design analysis is really good for spotting condition-consequence mechanisms so that we can see how organisms can relate to each other and control each other via interfaces. Design analysis, this is good. I'll tell you what this big long line says in case it blanks out. It identifies magical thinking in scientific papers. That's what it does, because engineers don't use magical thinking. And so, because Because microbes and humans, they don't just relate to each other partially well, they relate to each other really, really, really well. Really, really, really well. And so researchers, biologists who are not thinking like engineers, they see them so tightly close together, they in their mind, they imagine that this boundary and this boundary suddenly went away, and now they've become one with each other. And they call that, and this was taken out of scientific literature, a human microbe mosaic superorganism. Wow. A human microbe mosaic superorganism, or a transhuman collective. A transhuman collective. But that's not true. Microbes are microbes, humans are humans. They just work together incredibly close on that. And you haven't become one with the environment, and you haven't been absorbed into the collective, where resistance is what? Futile. I know, there we go. I knew who was after that. Resistance is futile. The microbe interface system augments an ability of creatures to rapidly fit and fill new niches and requires no genetic changes. Just a really cool mechanism to do that. And there we are. You just went through a scientific paper, not even being scientists, but you understand it, and hopefully now we're not just thinking about immune systems being an interface. We're looking at organisms in a completely different way with new approaches to do this. And this is part one. We'll pick up on Friday with part two on this. Thank you so much. Amen.